starting the illustration number 6, in which a sphere of mass 4 kg collides with a wall at an angle of 30 degree with the wall and rebounds in the direction making angle of 60 degree with its original direction of motion. So my first task is to find out the actual representation by a figure. So here is the figure which gives the situation arrangement of the statement of illustration number 6. Now, suppose I am considering in the figure that P1 and P2 I have denoted. So what are these P1 and P2? So let me suggest it first. The P1 is the initial momentum of sphere, and that is equal to P cos 16, because here the angle comes, I cap, plus P1 sin 60 degree j cap. Now, here only one sphere has been taken, and so there is no change in their mass and velocity, so I am directly substituting P1 and P2 as m into v. So this mv I am putting instead of m1 v1 and m2 v2. So here I am putting mv cos 60 I cap plus mv sin 60 j cap. Similarly, for final momentum of the sphere is taken as P2. It is written as, from the figure you see what is the direction of P2, and it is clearly seen that the direction of P2 is totally opposite to the direction of P1 in the x dimension only, and in the y direction both are in the positive y-axis. So for x-axis I have to put the negative sign. So minus P2 cos 60 I cap plus P2 sin 60 j cap is equals to minus mv cos 60 I cap plus mv sin 60 j cap. Now, why I have found out this initial momentum and final momentum? My task is to find out the force, but first of all I have find out the P1 and P2 means initial and final momentum. With these two quantities I can easily find out the change in momentum, and we know the change in momentum divided by the time ratio will give us the force according to the Newton's second law of motion for a system of particles. Therefore, the change in the momentum of sphere is given by delta P is equals to P2 minus P1. It is equal to minus mv cos 60 I cap plus mv sin 60 j cap minus mv cos 60 I cap minus mv sin 60 j cap. So see, these y components are cancelled out. So delta p equal to minus twice mv cos 60 I cap. And so the momentum I can find out by the mass is given by 4 kg, the velocity of the sphere, the initial and final velocities are same as 1 meter per second into cos 60 is 1 by 2 and here it is I cap. So here 2 is cancelled and therefore the change in the momentum is equals to minus 4 I cap kilogram into meter per second. So the momentum gained by the ball, because as this negative sign suggests for the ball, but the repulsive effect is taken place at the side of ball. Therefore the momentum gained by the ball is equal to 4 I cap kilogram into meter per second. Now, according to Newton's second law of motion, if I have to find out the force on the ball, so it is equal to the momentum gained by the ball divided by the time interval. Therefore, the force F is equals to the momentum gained by the ball is 4 I cap divided by time interval is of 0.1 second, that is given in the statement. So the answer is 40 I cap Newton, and hence this 40 Newton force acts on the ball in positive x direction. So this is fourth magnitude. Now we will see the last important parameter of the chapter as rigid body, and we will also find out its center of mass. Let's start the illustration number 7, in which a figure is shown, and this figure is representing a cubical type of box which is made up of negligible thin metallic sheet of uniform mass density. Here the length of each side of box is given as 40 centimeters. Then we have to find out the coordinates xcm, ycm, zcm of the center of mass of the box. So first of all, if we want to find out the center of mass of the box, then we have to get the geometrical coordinates of center of each of the slides, in ABCD here, CDX, also EF, HG, ABF. So we have to gather all the information about the different plates. So let's start to find out the coordinates of the center of each plate. So I am starting with the plate this A, B, C and D. My task first of all is to find out the coordinates of center, means here this is the center. So at this point the y coordinate is contributing 20 centimeter, x coordinate is contributing also 20 centimeter, but there is no contribution of z axis. So the coordinate of center is 20, 20 and 0. Don't forget to write down the units. It is very important because the length is given in terms of centimeter. Now I am taking the plate EFGH. Here if you see the figure, then again the center is inside the plate in which y direction is contributing 20 centimeter, x direction is also contributing 20 centimeter, but here the z direction, this is very important, see, is contributing full 40 centimeter of range. So the coordinates of center is 20, 20 and 40 centimeter. Now for the plate ABFE. So if you see the plate ABFE, so its center point is around this. So at this point, the x-axis, this side, there is the contribution of 20 centimeter. Also in the z direction, there is contribution of 20 centimeter. But in the y direction, there is no contribution. So at this point, the coordinates of center is 20, 0 and 20 centimeter. Similarly, if we move further and consider the plate DCGH, so here is the plate DCGH, then its center point is this. So what will be the coordinate? See, here the x direction is contributing 20 centimeter, y direction is contributing the full 40 centimeter of it. So its y direction will be 40 and z direction is having the half of the total value, so it is again 20. Therefore, the coordinates of center is 20, 40 and 20 centimeters. Now, the next plate is DCGF. So see from the figure, DCGF is having the center point around this. So at this point, there is no contribution towards the x direction, but there is equal contribution in y and z, half of the total value. So the coordinates of center is 0, 20, 20. Similarly, for the plate, this is the last one, ADHE. This is ADHE, so it is having around this. So here also there is full contribution in the X. So 40 centimeter of X, 20 centimeter in the Y direction and 20 centimeter in the Z direction. So the coordinate of center is 40, 20 and 20 centimeter. Now, with the use of all the coordinates of center, we can directly find out the position of center of mass system. Therefore, the position of center of mass system is RPM. See, I have not written the direction over here because there is another way for representation any vector quantity which I am using over here, and that is the coordinate system, in which it is not necessary that you have to put an arrow. Is equals to, now what is the value of x-axis first of all? So here the value of x-axis is m into the first plate ABCD 20, 20, 0 plus m into of the second plate 20, 20, 40 plus m into 20, 0, 20 plus m into 20, 40, 20 plus m into 0, 20, 20 plus m into 40, 20, 20. And this whole term will be divided by m plus m 6 times. So 6m. Therefore, RPM is equals to m into, see this x-axis 20 plus 20 plus 20 plus 20 plus 40. So it is actually 6 times 20. It is 120, also 120, and this is also 120, because the 0 and 40s are simultaneously rotating in the coordinate system. So I can directly substitute the values and add the below 6m. Therefore, the answer of center of mass will be 20, 20, 20 centimeter. This is the final answer. Now, the second question which was asked of this kind, if the box is open from the upper side, so when the box is open from the upper side, then this plate EFGH will be removed. So it is not present. And the mass of the remaining system. I am considering that mass as R dash Cm is equals to, see, it is very easy, you have to just neglect or minus this EFGH value. Therefore, R dash Cm is equals to X Cm dash, Y Cm dash and Z Cm dash. It is equal to M into 20, 20, 0 plus M into, instead of 20, 20, 40, now the next term is 20, 0, 20 plus M into 20, 40, 20 plus M into 0, 20, 20 plus M into 40, 20, 20. So it is easily seen that there will be change in the Z value only. Other values will be remaining same. Just minus 20 will be there. So that is equal to R dash Cm is equals to 100, 100 and 80 divided by 5m. So, the position of center of mass after removing the upper side, the final answer will be 20, 20 and 16 centimeter. So this is the final answer, and with this our chapter number 1 is over.